The Tauktae and Yas cyclones recently hit the Indian coasts. Like these two, past cyclones have also taught us that the coastal population remains at risk from tropical cyclones that arise from the Indian Ocean and the Bay of Bengal. Although, with the advancement of science and technology, the techniques to detect such disasters have improved remarkably. Yet, there is always a need for larger gaps between the detection and the actual fall of such catastrophes. Now, researchers from the Indian Institute of Technology, Kharagpur, have devised a novel method to detect the development of tropical cyclones over the North Indian Ocean region, and it could prove faster than the satellites. The method is based on detecting pre-cyclonic vortices that develop in the upper atmospheric column much before the development of well-marked low-pressure system over the warm ocean surface.
Our research team from the Department of Ocean Engineering and Naval Architecture, IIT Kharagpur, has developed a novel method for the early detection of tropical cyclones. Important aspects of this study was a thorough investigation on the formative stages of pre-cyclonic vortices that form as well as it develops over the higher atmospheric levels. Eventually, these vortices develop in size and migrate over the tropospheric column, and finally they subside down to the sea surface.
The research was carried out to develop a tracking technique to identify the genesis of pre-cyclonic eddies before the satellites can detect it. The researchers chose 6 cyclones for their case studies from the most active Bay of Bengal domain. Phelan, Varda, Gaja, Madi were the post-monsoon severe cyclones, and Mora and Ayla were the pre-monsoon cyclones. The researchers used a well-proven weather research and forecast model for the study, and a key indicative parameter called Okuba V's was derived using the wind components obtained from the model. The generation mechanism of tracking involved generation of OW parameter, identifying the possible locations exceeding the threshold value, continuous monitoring of these systems at the specific locations, and analyzing the movement as well as its intensification rate of these possible systems and their merging over a time domain basis.
Time series hormonal analysis gives the first indication of a strong OW parameter well before the satellite detection for all the case studies that we performed. The evolution and intensification and growth of this pattern is clearly visible throughout this time domain analysis for all the case studies that we performed. On an average, 90 hours of advanced prediction is possible through this tracking. We can possibly say that at what height and above what value of threshold for Okuba's parameter there are possible chances of cyclogenesis is going to happen. 2 types of grid sizes are used for this study. One is 27 km, that is a coarser resolution, and one is 9 km, that is a finer resolution. The coarser resolution is used for the identification purpose, and finer resolution is used for the structural analysis of these eddies which we are actually identifying.
The researchers also carried out a grid optimization study as an advanced analysis for this technique, using grid resolution of 27, 20, 15 and 12 kilometers, and found the 15 kilometer grid resolution to be the most efficient for this tracking algorithm. The technique has been developed under the Climate Change Program with support from the Department of Science and Technology, Government of India. This method can help ensure better management for protection against the tropical cyclones by reducing the loss of life and property in coastal areas. The research has recently been published in the journal Atmospheric Research.